some resource constraints like memory constraints, things like that. But if you are doing smaller tasks at a time, your model may not, or your prompt may not struggle with those. Instruction neglect. So if you are giving one big prompt of 20 lines, maybe it might neglect one like line from that. But if you are breaking it down and giving 20 different prompts, like that cannot be neglected. Contextual drift. So let me read actually about contextual drift. What do they say? So contextual drift, where the model loses track of the initial context. So, but if you are breaking it down into smaller prompts, then you are providing the right context with each step, right? So that is another limitation that was for single prompt. Error propagation. तो ये वही अभी हम बात कर रहे थे ना कि if there is a, let's say, that team building event, you would have seen, right, that one person does some action, then it passes on to another one, that person copies and passes on to the third one. So if any one person makes a mistake, that error kind of propagates and builds on top of each other, right? So same thing, there is error propagation in things. If your model actually takes one wrong turn, then it can actually lead to a very like different or inefficient result.
Yeah, but you are saying this is the pro or cons of the?
No, for single prompt, one single prompt, there is no way for you to correct that. But if you break it down into smaller tasks, smaller prompts, then if, let's say, you can do actually validation after each step, and you can course correct.
Oh, I was thinking for the breaking down, this might be a problem because if you have let's say due to any reason there is a flaw or something and it propagates, and once you are done, if you didn't notice, then it will keep on propagating further and further.
Yeah, if you did not notice, right? That's the key, right? So here, in case of single prompt, there is no way for you to notice. Like, you don't have the visibility of how LLM is breaking down that single prompt into individual tasks, and you don't have any opportunity to validate or course correct. But if you're breaking it down yourself into smaller tasks, you can actually validate, verify after every step, and you can correct that error.
What about the context? Let's say, I mean, I saw you said it just before. Let's say the context, I mean, we have a number, right? This much of data we can put in context. So in this case, do you not, how the LLM will remember the previous context, or it's not required? It's completely stateless kind of thing.
Previous context, you mean like in the series of tasks?
Yeah.
Yeah, so you will actually provide that context with every task. So you will provide that previous context also. Basically, you'll provide all the context that's necessary to do that specific task.
Yeah, I'm saying if the context will increase, it go on and on, right?
Yeah.
So
Yeah.
will that not? I mean, is that not a problem because we have context limitation, right?
Right. So actually, it's the other way around also, right? So in the single prompt, you have to provide all the context that may not be needed for all the tasks. But in case of this prompt chaining, for smaller prompts, you can only provide the context that's needed just for that task. There could be other contexts also that may not be needed for this task. So you can actually reduce the context size in that case.
Yeah, that's a good point. Okay.
That's what actually it's saying, that requires longer context window if it's a single prompt.
Oh,
Then, hallucination increases cognitive load. Your model or your LLM is having to think a lot, so it can. There are more opportunities to make an error or hallucinate. And then there was an example of market research report analysis. So let's say, I think this one, for example, a query asking to analyze a market research report, summarize finding, identify trends with data points, and draft an email risk failure, as the model might summarize well but fail to extract data or draft an email properly. So they're saying, yeah, so that's an example of one single big prompt, but there are more opportunities for failure.
And one more, I mean, thought. I'm not asking you. I'm just loud thinking. So after each, what is that called? Chain of each thought. Do we need a process for validation?
Yeah, I think they actually mentioned that later in this chapter that after every step you can actually have a validation step.
And that is also part of, let's say made a four process, what is that called, let's say
Yeah,
four steps, say. So after each step, let's say in the second step, I will put, okay, validate the previous step,
yeah,
then these are the chain of the, I mean, these are the thoughts for my next one. Then
yeah.
in the third, is that the same way, like?
Yeah, let me. I think they have a diagram also towards the end. Let me just jump to that. Uh, yeah, this one, right? So
Mm,
they say that you give it a prompt, agent works on that prompt, the agent gives an output, you're including some context, and then you're giving it to the another. That whole thing, like input and the original context, goes to the agent. Actually, no, this one does not talk about validation, but
mm.
somewhere in this chapter they talk about that you can validate, verify after every step.
Okay, okay,
Actually,
okay.
the pattern that we are discussing here, sir, uh, is the chain of prompts, right? So,
Mm-hmm.
chain of prompts. The moment we are talking about the validation thing, the validation means either it passes or it fails, right?
Mm-hmm.
So that requires a different route to manage, right? So if that validation pass, what to do, and if that fails, what to do.
Mm-hmm.
But here we are just talking about we have a big problem, and we have split that problem into three or four steps, and then we are executing them sequentially. Very simple.
Mm.
Yeah,
So isn't it like something similar to debugging we used to do when बहुत पहले हम programming करते थे C में or something like debugging. What's the input, what's the output, and is it acceptable or not?
yeah. If you have visibility into what are the smaller steps, right? You can debug better.
Yeah.
Mm.
Yeah,
Like one example coming to my mind, let's say, I mean, we are asking to generate a code, write unit test for that, and then just do the testing, right?
yeah,
So it can be segregated. Okay, generation of code is a one process, then writing
Yes.
unit test on top of that one with the way we are writing, that is another process. Then third is the run, that makes sure it is
yeah.
okay.
So now they are talking about the benefits of that, again, prompt chaining. Uh, Enhance reliability. So that's what this section is about. Enhance reliability through sequential decomposition. So they say that it addresses single prompt challenges. So one prompt at a time, breaks into focus and sequential workflow. There is some market research pipeline example. Let me see which one is. Yeah, probably the same example, right? So initial prompt is summarize the key finding of the following market research report. Somebody gave some report, right? The model's sole focus is summarization, increases the accuracy of this initial step. Then second prompt is using this summary, identify the top three emerging trends and extract the specific data point that support each trend. So that is second prompt. And then third prompt is draft a concise email to the marketing team that outlines the following trends and their supporting data. So this is just an example of how you can enhance the reliability by breaking it down into smaller tasks. More granular control. That's what we talked about, right? After every prompt, you can verify, validate. Reduces cognitive load on models. We talked about this earlier. Analogy, computational pipeline. So actually, yeah, similar thing as Ashish was saying, right? We do these things already, right? Instead of um, creating one monolithic code, we already in our like computational, like regular any kind of computational pipelines, right? Like whether it's like
Yeah, even the Manoj, that single responsibility pattern also
yeah,
represents.
yeah, exactly. It's the same single responsibility principle, exactly. Yeah, assign distinct role at each stage. So this chapter, like it's one simple concept, they just created a whole chapter out of it. Should have been just a paragraph, but anyway. So then they talk about the role of structured output. You say that instead of asking for your LLM for every step, instead of asking it to give you a output in a natural language, you should ask for the output in some structured format like JSON or XML, because then it can be a little more like deterministic, and you can validate that easily. So, like the first prompt was that give me the trends from this report, right? So, or from the summary. So, if you ask that give the output in this format where there are like JSON array of trends and each trend contains trend name and supporting data, then you can actually verify that, oh, is it really giving me 3 trends or not? Because I asked for 3 trends, it becomes easier, right? So role of structured output is crucial for reliability. Uh, it prevents ambiguity and poor formatting. Ambiguity and poor formatting in the like natural language. Uh, Comparing with that, you specify JSON or XML format, whatever suits for you, and ensures machine readable data. This is machine readable data, right? And it minimizes natural language interpretation error. So there is no ambiguity again because of natural language. Makes sense, right?
Yep.
Practical applications and use cases. So then they talk about these 3 things, that summarizing, extracting, querying, reporting. Let me actually read this. So they're saying many of the tasks involve processing raw information through multiple transformations. So make every transformation a separate prompt. So steps would be like, for example, extract text, summarize, then extract entities, then search some knowledge base. So this is that integration with external sources that comes here, and then generate report. So these are just some examples that they're giving. Um, so they're saying that this methodology is applied in domains such as automated content analysis, development of AI-driven research assistants, and complex report generation. Complex query answering. So when you answer complex query, you create multi-step reasoning or retrieval, different steps. Example, stock market crash. Let me go to that example. So they say that, for example, the question is, prompt is, what were the main causes of stock market crash in 1929 and how did government policies respond? How would you break that down into smaller prompts or chain of prompts? So first prompt would be identify the core sub questions in the user's query. So causes of crash or government response, these will be the sub questions. Then research or retrieve information specifically about like each query, right? So specifically about the causes of this 1929 crash. The next would be research or retrieve information specifically about government policy, and then synthesize the information from step 2 and 3 into a coherent answer. So each of these workflows are going to be very task specific. So that's what we discussed. Then integral to multi-step inference system and combines parallel processing, data gathering with chaining, synthesis and refinement. So like in this step, prompt 2 and 3, they can be run in parallel, while prompt 4 has to wait for the output of 2 and 3 to synthesize the response. Data extraction and transformation. So this one says that it's an iterative process for unstructured text. And then the steps are that you extract fields, validate them, conditional reprompting, then validate, and then output. So yeah, Niharsa, that's where I think they're talking about validation. So if you have, like, first prompt is in this example, first prompt is attempt to extract specific fields. So somebody gave a prompt that contains some in the English language, and you're extracting specific fields. Then you check if all those specific fields they meet the format requirements. If any field is missing, you can actually ask the model to kind of find those specific fields that, oh, you didn't actually find the amount, so look for amount again. Or maybe the amount was mentioned in, let's say, in words, but you want it in numeric, so you can ask for that specific format. Then you validate the result again, repeat if necessary, and once you have all the information, then you basically validate the structured data. So, so that's what like that's an example of where you can actually you can kind of interrogate the output, and before putting the input, before giving that as an input to other models. OCR problem. So there is a OCR problem that there is. So for example, solving complex OCR problems, just processing a PDF form, is more effectively handled through a decomposed multi-step approach. So yeah, I mean, I can imagine that in case of, like, let's say, if you have a PDF form, or if you're processing an image, maybe you can break it down into, like, let's say in case of OCR, you can break it down that OCR each word separately and then combine together to form a sentence, or break it down into each character separately. Then it integrates external tools. So calculator for math, for example, they're saying that um, if any, let's say, any step or any validation requires some calculation, you can use external tools like calculator or any API call. Any comments so far?
So another thought, it is kind of the task, this task who will do that is kind of an orchestrator, right?
Yeah.
So that will also be an agent.
Very good question, actually. So in this chapter, they did not talk about that. In this chapter, they have given an example later, or code later, where you have hard coded that whole orchestration in your code, right? But in like in the agentic workflows, that's not how it's done. In agentic workflows, you create separate agents. Each agent can do only like one task, and it clearly specifies like what would be the input and what would be the output. Then at a higher level, you create a prompt to LLM saying that this is my like this is the job that I need to do, and these are the AI agents that I have at my disposal, and these are their capabilities. Actually, LLMs can directly query the AI agents to figure out what their capabilities are, and then figure out in what order, how should they be called, figure out a workflow for me, right? So LLM can does that for you. So that's the dynamic workflow generation part, but this chapter does not go that far.
And so this is very good thing, because I was wondering while in the session how this thing is different than any system design, because system design also we do the modularization, different modules doing the different things. So this makes lots of sense.
Yeah, and another thing is that, let's say there are some long run agent here, right, collecting data. It's huge amount of data or something, and you are the way we are reading right now, it will be a manual process. Let's say after one, then we need to do this, then that, then that. So you cannot rely on, okay, I'll just do this and leave it and come after, let's say, tomorrow, and maybe my data or everything will be ready.
Yeah. So next example they have given is about content generation. So if, let's say, I think in the example is that you have some task that includes ideation, then structuring, outline. So let's go through these prompts. So the prompt one is generate 5 topic ideas based on user's general request. Allow the user to select one idea or automatically choose the best one. Based on the selected topic, generate a detailed outline. Write a draft section based on the first point in the outline. Write a draft section based on the second point, and basically they're writing all these draft section for each point. Then review and refine the complete draft. So like for content generation also, you can break down the content generation into smaller steps. So yeah, these are the steps, right? And then automated composition, narrative, and documentation. These are some of the use cases where you can use that. conversational agent with state. So they're giving different kind of use cases, examples of how you can use this prompt chaining for different for like different kind of use cases. So in case of conversational agent that has a state, you can say like they've broken down one particular prompt into these two or three prompts, saying that process uses utterance one, identify intent and key entities. Then you do like you're about update conversation state with intent and entities, right? You're maintaining that conversation state in your own workflow. Then second prompt is based on the current state, generate a response and identify the next required piece of information. Then you repeat and you ask user for like any other information that's needed to do the job, right? So let me see if I have covered this whole thing. Maintains conversational continuity, constructs new prompts with preceding interaction, and these are the steps. We discussed that fundamental for context and coherence. Yeah, so this principle is fundamental to the development of conversational agents. Code generation. I think we were talking about this right earlier. So in code generation also, you can do this multi-stage kind of process. So you understand the user's request for code function, generate pseudocode for an outline. Then you write initial code draft based on the outline. Then you identify potential errors, and then you kind of fix those errors, rewrite the code, and then you add documentation or test cases. So you've broken down one code generation task into multiple prompts. So multi-stage process, decomposing the problem. There are these different steps for code generation. AI-assisted software development. That's what all of these co-pilots they use. It allowed deterministic logic between model calls. So between each model call, so that logic of like that first you'll generate pseudocode, then you'll generate initial code, then you'll test it. So that's the determinism they're talking about. So that's a hard-coded workflow that you have in your code generator. Multi-model and multi-step reasoning. So this is another example. If you're interpreting an image that contains a picture with embedded text, you have a picture and then there is also some text. So how, like, instead of giving both of them together and ask the LLM to analyze that, what if you give the picture, extract and comprehend the text from user's image, then link the extracted image text with the corresponding label, and then you interpret and gather information, right? So you are actually kind of helping the LLM by giving steps, right? That first look at the image, then combine it with the label that's provided, and then you create the response. So now practical things, like how do you do it? What are the tools available to you? There are these frameworks available: LangChain, LangGraph, True AI, and Google Agent Development Kit, where you can actually give the chain of prompts, or you can create a graph. Like we talked about that some prompts can be executed in parallel, some needs to be executed in sequence. So you can create that whole graph in your code, and then these frameworks will execute that for you. So just I think this is a very simple example where they created one prompt. So some extracting the information. So the prompt is extract the technical specification from the following text. Text is given by the user. Then second prompt is transform. So which is transform the following specification into JSON object with CPU, memory, and storage as keys. And so now they're building it. So the extract prompt, the first prompt that they generate, so that's the extraction chain. And then they created full chain by adding prompt transformation to the extraction chain. right? And then they're running the chain. So let's say the input was the new laptop model features says whatever, like the specification. Now output would be, it's actually figuring out, it's telling you like in a JSON format, uh, all the information, right? Like let's see what was the prompt. Yeah, with CPU, memory, and storage as keys. So from the user's prompt, it's extracting that in the JSON format, and then you can use that in any further prompts. So that's a smaller example that they have provided. Let me just make sure that I've covered this whole section. So sequential function calls or specialized frameworks. So these are the frameworks that we're talking about, like LangChain, LangGraph, all of that. They are suitable for chains or graphs. Example, two-step data processing pipeline that we just saw. Again, they're talking about the same libraries. Uses chat, OpenAI, chat prompt template, and yeah. So this just trying to interpret the code, nothing much. So input is the laptop specific text, output is some JSON string of CPU, memory, and storage. I think we covered this section. Any comment on this? Okay. So next section in this chapter is context engineering and prompt engineering. So this is actually first time I'm hearing this term context engineering in this book. So what they're talking about is that all the prompts that you provide, there are many different ways to provide the context, right? We have like we know what is RAG, right? In RAG, you are providing relevant context along with the prompt. Same way, prompt engineering is also kind of adding more to the context to whatever user provided. Structured outputs, we talked about that, memory and state or history, they are all uh, one or different form of context. So, like all of this is they're clubbed into as a context engineering, and prompt engineering is part of that. Prompt engineering is one form of context engineering. That's what they're saying. So let me go through the mind map for this too. So they're saying context engineering is a systematic discipline designing complete information environment for AI. Its quality of output depends on the context richness, of course, right? Like if you provide better context, you'll get better output. Evolution from traditional prompt engineering. So uh, instead of just prompt, now you're also controlling the context. So that's an evolution. Expand scope beyond immediate query phrasing. So yeah, not just like query, you're just rephrasing the query, you are also providing additional context. Then there are layers of information that you're providing, right? Like for example, with RAG, you provide, you look up the data in your database or some index, and so there are layers of information that you provide in the context. Reframe task, building operational picture. So let me actually see what this actually say. Reframe task, building operational picture. I don't know. Yeah, so they say that in practice, therefore, reframes a task from merely answering a question to building a comprehensive operational picture for the agent. So instead of just, so you're providing the whole structure of to the agent, how to answer this question, right? Then creates robust pipelines for data fetching and transformation. So yeah, like each step is separate for data fetching, transformation, so you can build some reliability there. It established feedback loops for context improvement. So we saw that like if you're extracting some information, if something was missing, you can actually ask for that specific information. So you're kind of improving that context. I think that's what they mean here. Uses tuning systems. So there are these tuning systems also available, like Vertex AI Prompt Optimizer. Let's see what they say about that. So it says that specialized tuning systems can be used to automate the improvement process at scale. For example, tools like Google Vertex AI Prompt Optimizer can enhance model performance by systematically evaluating responses against a set of sample input and predefined evaluation metrics. So yeah, these prompt optimizers are available already that can evaluate the responses from your prompts. Differentiates rudimentary and sophisticated AI, of course, right? Like if you have only prompt versus now you can also provide context, you can build more sophisticated AI tools and agents. And it's crucial for advancing stateless chatbots to situationally aware systems. So now with context, your system is more aware of the basically context or situation, right? Any comment, question on this?
No, it looks good.
So I think that concludes this chapter. There are a bunch of summarizations that they do. So let me go through them quickly. At a glance, what it is complex task overwhelm single LLM prompts. So instead of that, you break them down into smaller prompts. It increase it increases cognitive load, and that leads to errors of different kind, neglect, drift, or hallucination. We talked about that, and struggles with one single prompt struggles with multiple constraints and sequential reasoning. So instead of that, you help the LLM by breaking it down into smaller tasks. Why are you doing that? So you have standardized solution. You focus prompts, uh, improve if you provide focus prompt, then that improves reliability and control. Output passed as an input, so you're creating a logical workflow. It's more modular, divide and conquer strategy, easier to debug, integrates external tools and structured data. It makes it easy to do that, right? And it's the foundation for sophisticated agentic systems. Rule of thumb: uh, if task is too complex for single prompt, then you need to basically break it down. Involves multiple distinct processing stages, requires external tool interaction, and building agentic systems needing multi-step reasoning or state. So same diagram that we saw earlier. Now key takeaways again, I think repeating the same things, that breaking the complex task into focused tasks, improving reliability, and then there are these frameworks, LangChain, LangGraph, Google ADK. Yep, that concludes this chapter. So this is what I liked about this book. The chapters are very small. You can easily cover them in like 1 hour reading or half an hour of review. Yeah,
So I have a question, sir. Like how to I will apply this knowledge to create an agent. In my company now, they have given one interface to create your own agent to do your some productivity related task or your daily activity task.
yeah,
Use agent. Now, what I understand, like so in that screen, they just give me the like you can provide your system prompts, right? And then you can select some parameters like temperature, all those things, the model, everything, and then they
mhm,
have provided some like a collections. So collection in the sense like whatever the database access you have available that you can query, and some tools and sub agents. These are the options that I can use, and they are asking like, okay, now use your creativity, create agents for your or your own use your work related. Like for me, like we are a security department, so we have to create some kind of security champion AI agent which can help developers to find the security bug or some security vulnerability in the code. So with that interface, this knowledge how they relate. I can write with a single prompt, right? Nothing else I can do. So how I use this prompt chaining techniques into that kind of the situation, is it still makes sense? Or it is more like, or this is like more on the more like on developing your own agentic framework, whatever the agent UI they have given me to develop. I think this this information gonna useful to developer to create their agent UI, not for me to create an agent.
Mhm. Yeah. So, like, if you see any code, right, that we saw, there are a lot of there is a lot of like scaffolding kind of code. Like prompt is only there are only two prompts, right? Uh, One was I think this prompt one, and then there was that prompt two, right? But a lot of there was like scaffolding code and all these import and everything. So this is going on in every company. Everybody is building their own this agentic frameworks. So it's easier for developers to write these agents, right? Like in my small company, there are like at least five frameworks that developers have built so far. Um, I've heard like same thing going on in Google and every company. So it depends on how rich that framework is. That framework could be just as simple as like you give the prompt and I'll convert that into an agent, or it can do more sophisticated things like prompt chaining or uh, agentic workflows, right? So it depends on the capability of that framework.
So this chapter is like gonna help to create the agentic framework, not like the end user to create an agent. Like for me, I don't care like what the agentic this say.
No,
Whether you
this
are using prompt or not, I have to give one prompt like simple line. Okay, read this code, find the security vulnerabilities, and provide the mitigation. My prompt is like as this simple, like it's a 3-line prompts.
I
That why
think
what I do actually to send to the copilot the piece of code and say, okay, review this
I
code.
think
And
Shyamji, we can park this question and we can discuss after 9:30, because we have to complete one more chapter today, right? So
oh,
that
okay,
has only 14,
okay,
15 minutes. So we can discuss this thing. So you have raised a very valid query on this. So that needs a discussion also. We can share our thoughts and ideas on that, right?
okay, okay, yeah, yeah. What?
ठीक है,
So
ठीक है.
shall we
So I'll
go to
stop
the next
presenting
chapter?
and I'll let you present chapter 2.
Okay. Let me know when my screen is visible.
Yeah.
Okay. Yeah, thank you, Manoj. And so this is a very nice collection of design patterns in this book. So everybody knows, right? What is a design pattern? So design patterns are nothing but they are the proven solution for some known problems, right? So in the past we have done a lot of mistakes that we have applied a wrong design pattern to a wrong problem, and that can happen in agentic design problem design pattern also. So in order to read any design pattern, we should know what problem it is trying to solve and how it is solving. How part is the pattern name. For example, there is a factory design pattern, or there is a singleton design pattern, or there is a chain of responsibility design pattern. Similarly, this author has created few agentic design patterns. So there are around 21 design patterns. Not 20, yeah, 21 design patterns, and it has a very good collection of appendix also. So here in this, we are trying to cover two design patterns in every session, right? So Manoj has covered this prompt chaining design pattern, where that Y part, right? Just read the Y part of the previous chapter. Means when we need this pattern to be applied, when our task is complex, then we can divide it into simple steps. That's simple, right? Similarly, now in the next chapter, routing, we are going to discuss another design pattern, and we want to see what are the pros and cons of the previous design pattern that we cannot able to solve it, and how using this technique, routing design pattern, how what type of problems we are going to solve. So there are n number of problems, right? So only we will focus only on the specific part of the problem, and then see how this author has recommended different solutions for the same, right? So in the chaining design pattern that Manoj has just shared, we have a deterministic linear flows. We know what is going to happen, and we know that it is going to happen in the linear fashion, right? It's good if we know everything in advance. It's good, but what about the dynamic decision making? So wherever we need this dynamic decision making sort of thing, there we need routing. Either we have to go this side or this side. Learn any computer language, right? What is there in a computer language? We are declaring some variable, then we are writing the algorithm, and we are actually implementing our algorithm with the help of if clause, right? If, else, for, loop. This is what is present in every uh, programming language: Java, C, C++, any language, right? So what this if statement do? If actually decide whether I have to go this way or that way. That's it. So this is what that if is need to be present here, and that term here we are using is in the form of dynamic decision making, right? So where we can apply this thing, we can apply this thing to the customer query, because customer can ask any type of queries, right? So first we need to understand, is this customer is talking about some complaint, or is this customer is talking about some billing issue, or is this customer is talking about some he want to buy, or about to know something more about the product, right? Different people are there who are going to serve these things, right? One people cannot solve all the things. So for example, this customer inquiry, so the classification should be the first step to understand, okay, this customer is looking for this solution. So based on that, we can ask him to, okay, go to agent 1 or 2 or 3. That's simple. Right? This is what here, these are the basic steps, right? First, we need to analyze the user query. Then we need to understand its intent, right? If its intent is to check the order status, we can, okay, ask, okay, whoever is my tool agent who's checking with my order database, let's handle that agent this customer query. If he needs some information about the product information, right, then then the product catalog agent need to be uh, connected for this query, right? Similarly, technical support, right? And suppose those intents are not present, he want to ask some another vague question for which we don't have any agent. So what we can do, okay, we can connect him with the customer care person. Okay, let him talk face to face, and then they can help you to resolve the query, right? So, and okay, so I think I have given a fair idea about where we need it, right? Where we need it, right? So this this routing concept where our lot of things are to be there, and we have separate agents who are actually handling their respective areas. So first we need to understand the intent or the area or to classification of that query, then that classifier we need to associate with that. So now there are multiple ways in which this classification we can do. First is the LLM based routing, right? What is this LLM based routing? We can write a prompt. We can write a prompt to analyze the intent. For example, we can write something like this: analyze the following user query and output only the category, which is order status, product info, technical support, or other, right? So what my prompt will return me? Only one of these three strings. So, and now with the help of these three strings, we can understand, okay, now who to whom I should contact. If it is other stated, we have our own agent, right? If it is product info, similarly other, right? So this is how this works, LLM based routing, right? So this is one of the technique where we can use this routing design pattern. Another way is to use embedding based routing. What is embedding based routing? Means user has given us a query, right? And we have embeddings of the different agents, right? Only the agents. Now, based on this query, we want to understand to whom agent this query is very near. Then we can associate that agent to this query. It is similar to a RAG technique, right? If we store everything into the vector spaces, then a user query come, and the output of that user query is again the same thing, intent classification, right? So this is one thing. This is another way of do this thing, routing. First thing is LLM based routing. Another thing is embedding based routing. Third one is the rule-based routing. We have created rules like we are discussing, right? We have split our complex prompt into different steps. Similarly, here we can define some rules. Okay, agar if there is some query coming between 10 to 12 a.m., I can route it to agent A. If it is coming between 12 to 2, we can route it to agent B. I'm just giving a very means one of the example in which we can apply this rule based routing, right? So we can define our some rules, right? Based on those rules, our agent is getting selected, right? Another powerful technique to do this routing is using machine learning models. We can create some models, and the output of the model is the classification of that route. Right? We can create some model, and how can we create those models? Using this fine tuning model by changing their weights and all those things. Right? We can create a small LM, and then that SLM is giving us a response. Okay, as per the SLM, this the intent of this user query is this. That's it. Right. So we can create those LLMs. Right. And this is not something which is we can apply only at the start. Right. We can also there are multiple junctions where we can apply this routing design pattern. One at the start, right? Other like they classify the primary task. Other could be our intermediate points also. Whenever we are doing some work, we are running some workflow or we are running some job in between at any point of junction, we can divide. Okay, now we need to apply routing design pattern. So there we can use this pattern and decide. Okay, now we have processed so much flow. Now here we want to split our ways, either this way, this way, this way, right? Now, as in the previous example, LangChain, LangGraph, and Google Agent ADK are currently in the market, right? People are using them very frequently. So we can discuss the code and so people can go through this LangChain, LangGraph, and Google Agent. They have their official websites there. One can actually see the details. I will try to share one example of LangGraph today for the routing. Right now, the practical use cases where we can apply these use cases. One is the virtual agents, right, where any query can come, or the AI-driven tutors, right? Uh, Whether the student want to understand English, maths, physics, right? So depending on that, respective tutor can be respective tutor agent can be forwarded that request. Yeah. Another way is very strong, good and powerful way is automated data and document processing pipelines. Right. So we have in our pipeline a lot of data are coming, and we need to check. Okay, whether this is a email or support. We have received some data. It's a support ticket or the API payload. Means what type of mail is this? Based on that, we can actually run the processing data pipeline. We can use it in the high level dispatchers, right? We can use it in the AI coding assistant. I want to write a code in Python. I want to write a code in C Sharp. I want to write a code in React, right? Or I want to write some script, right? User can ask anything, but we have different agents who can do this job. So depending on that, I can connect to those agents, right? I think most of us are using few AI coding assistants. Right. So now some hands-on code. Uh, so for coding part, what I will try. Okay. So this is a LangChain example. Here some input query came. Now here the route has been given. Okay. Let it be handled by this person, or this person, depending on this. So the code, if we want to see. So here like. We can get a graph. So graph, what is a graph? Graph is nothing but it's a collection of nodes and edges, right? Every node is you can say is associated with a Python function, right? And there is a overall single state which is actually being shared among all the nodes. This is how most of the LangChain examples we can uh, get into, right? For example, here we have created this as a state. Now these are the nodes, right? LLM call 1. What it is doing? This person is actually writing a story, right? What is LLM call 2? What this person is doing? This person is writing a joke. LLM 3. What this person is doing? They are writing a poem, right? So now the router, what the router will decide? Router will decide, okay, based on the user intent, I need to pass it to whether I need to write a story, joke, or whatever, right? So this is our the router decision node, right? Then what can I do? I can get a graph. I can create these nodes. I can start the node with the router, and in the router I can analyze, okay, to which node I need to route, right? So it can say, okay, LLM call 1, 2, 3, right? So and when the LLM call 1 is finished, then I have added another node which is end. Right? This graph is nothing but this graph only. You can take, okay, this is the poem, this is the essay, or this is some other story, right? So this graph is there. So then we need to execute it and give the query. Like here we are talking about, okay, write me a joke about cats. So what it will do? It is going to execute only joke part, right? This function it is going to call. Right? So this is how. So in order to execute them, so we have LLM. So this example you guys can go through. I have shared another example of the from the LangChain, right? Similarly, they have given another example of ADK, and so I think we have understood the why part, right? Where we can, when we should apply, why we should apply this router design pattern, right? And then the rule of thumb means this is the important question: when we should apply, right? Using the router when an agent must decide between multiple distinct workflows, tools, or sub agents based on the user input or the current state. Remember this line always whenever you want to use router design pattern. Because see, what is a design pattern? Proven solution of a known problem. Without getting into the problem, we should not